Welcome to qnawire.
As we can see in the figure, we are given two blocks having same equal masses 1 kg. They are resting over this wedge. If we leave this two block over the wedge, then we have to find what will be the acceleration of both the blocks. Basically it will be same, because as they are connected with the same string, and as the string is inextensible, so acceleration of both the blocks are going to be same. So let's say acceleration of both the blocks are a. Okay, now suppose this angle is theta 1 and this angle is theta 2. So as we can see, the side length of the wedge is 3 meter, 4 meter and 5 meter. So this is a right angle triangle. This angle is 90 degree. So from the figure, then I can just say that sine theta 1 is going to be 4 by 5 and sine theta 2 is going to be sine theta 2 is going to be 3 by 5. If sine theta 1 is 4 by 5, so from here I can write that theta 1 is going to be 53 degree, and as sine theta 2 is 3 by 5, so I can write theta 2 is 37 degree. So as we can see, theta 1 is more than theta 2. That imply that this 1 kg block is going to slide downward, the left side one. This is, let's say, first block, and this is, let's say, second block. So the first block is going to slide downward with the acceleration a, let's say. So if this block is sliding downward with acceleration a, then second block will slide upward with an acceleration of same a. Okay, now let's try to find what are the forces acting on both the blocks. Now on this first block, as its mass is 1 kg, so the force due to gravity will be acting downward, which will be 1g, which is nothing but g. A tension force will be acting due to the string, along the string, so that will be T, let's say, and a normal reaction force will be acting in this direction, which is, let's say, N1. Okay, on the second block, again as its mass is 1 kg, so the force that due to gravity will be acting vertically downward, that will be G only. A tension force will be acting along the string, which is T, and a normal reaction force will be acting perpendicular to the contact surface, that will be, let's say, N2. This G force, I can take two components. One will be perpendicular to the surface in contact downward, as this angle is going to be theta 1, so this component will be G cos theta 1, and the other perpendicular component will be along the inclined surface, that will be G sin theta 1. Similarly, for the second block also, its one component will be acting downward, which will be G cos theta 2, and the other component is going to be G sin theta 2. Now if I draw the free body diagram of, let's say, first block, then we can replace the first block by a point. On this point, T force is acting like this, which is the tension force, and the G sin theta 1 force is acting like this, G sin theta 1. The normal reaction force N1 is acting like this, and G cos theta 1 is acting like this. So then, as this first block is moving downward with an acceleration of a, so we can write the Newton's second law in the case of the first block along the inclined plane, which will be along this G sin theta 1. So the net force will be G sin theta 1 minus T, which has to be equal to M1, which is 1 kg, into the acceleration a. So let's say this is my equation number 1. Similarly, we can draw the free body diagram of second block, FBD of second block, as we can replace the second block by a point. On this point, the tension force is acting in the upward direction, and the G sin theta 2 force is acting in the downward direction along the inclined plane. A normal reaction force N2 is acting perpendicular to the inclined plane, and G cos theta force is acting like this, G cos theta 2. And due to this, the whole block, second block, is moving along the inclined plane upward with an acceleration of a. So in this case, if I want to write the Newton's second law by applying it along the inclined plane, then we can write, in this case, T will be more than G sin theta 2. So T minus G sin theta 2 is going to be equal to m into a. What is the mass of the block? That is 1 kg into a. So let's say this is my equation number 2. Okay, now if I add these two equations, equation 1 and 2, so I will just write by adding 1 and 2, we will get G sin theta 1, G sin theta 1 minus G sin theta 2 is going to be equal to 2a, or a is going to be G by 2 sin theta 1 minus sin theta 2. Now if we put the values, we will get a equals to G by 2, let's keep it G as it is. Sin theta 1 we got 4 by 5 minus sin theta 2 we got 3 by 5. So this will be a will be equal to G by 10. Okay, and now if we take G as 10, if we take G as 10, in that case the acceleration of the block is going to be 10 by 10, which is 1 meter per second square. We can take G as 9.8 also, so in that case it will be 0.98 meter per second square. Here I have taken G as 10.